Fantastic. So we are here to talk about push notifications and progressive web apps. So my name is Owen Campbell-Moore. I'm a product manager on the Chrome team, and I help make the web a more appy platform with rich capabilities like push and add to home screen.
Hi, I'm Nate Schloss. I'm a software engineer at Facebook, and I built our service worker push implementation. And in general, I work on our use of service workers and making the web fast.
So progressive web apps, like I personally feel like we're at this point that feels very similar to me like it did in the early days of like Ajax or HTML5, where suddenly we're turning around and saying like you can do so much more in the web than you could do before, and everybody is just like we're all just realizing this. I feel like on our team we've just been realizing this, and it's more of like all these new features have come together and kind of accumulated in a similar way to HTML5 and Ajax and kind of add up to something bigger. So I think that's really exciting. And specifically, I think push, what we're here to talk about today, is so important because when you look at mobile, you see things like WhatsApp and Facebook, like messaging, social, that's only been possible because push notifications. And that's not been possible on the web because you didn't have push notifications. So the fact that this stuff has come to the web, I think is huge for everyone and has created a lot of new opportunities. So this is the plan for the talk today. Firstly, we're going to talk about what push notifications are and what you can now build with them. Secondly, why Google and Chrome cares about this, why web browsers care about this, and why Facebook cares about this. And then thirdly, how do you implement them? So we'll dig into the code on how you can get up to like a hello world push notification going. So now I'll turn over to Nate to talk about the what.
Cool. So I'm going to show a quick demo of what this looks like. There you go. Cool. So you're on your phone. Somebody maybe is posting on my wall. So my browser is going to get a push notification. It's going to wake up a web worker, which is going to display the notification. I can click on it. Then the same web worker is all right, Chrome, navigate to this URL. Chrome navigates to the URL, and then I can see what was written on my wall. Fairly straightforward. It looks a lot like a native push notification, except the cool thing here is that it's in the browser, and it's not running from a native app. So one thing you didn't see in there is notifications from the browser can also have custom actions. So you can have a custom button. Clicking on it will work pretty similarly to how clicking on the notification would work, but it's just another thing you can have there. One of the great things here is it's already in prod today. So you can go out today and on Chrome desktop, mobile, and Firefox on desktop, and Opera, you can go ahead and already use these web push technologies. Facebook's already doing it in Chrome. Another great thing is it's going to come soon in Edge, and we've yet to hear about our friends from Safari. So now we've talked a little bit about, now we've talked about the what, we're going to talk about the why. So for Facebook, why would we care about web push? Well, in general, Facebook cares about the web. As a mobile-first company, the web matters. The mobile web is a key part of our overall mobile strategy. When we say that we're mobile-first, that doesn't mean native only. Mobile-first means mobile web as well as native. Both platforms kind of go hand in hand. And you might be worried, all right, great. So I'm going to focus a lot on my mobile website, but maybe that'll take away from a native app. Or I'm going to focus a lot on the native app, and that'll take away from the mobile web. And that's not really what we see. The mobile web's growing, and it grows right along with native. Both platforms kind of complement each other, and we don't see growth take away from one. Like, we don't see growth on one platform take away from the other. When we see our native apps grow, we see the mobile web grow right along with it. We don't really view them as competing. And the mobile web's especially important to us in markets like India or other emerging markets, where maybe the barrier to downloading a native app is higher, and it's a lot easier just to navigate to a mobile website. In these markets, the mobile was often people's primary interface for interacting with Facebook. And similarly, Facebook cares a lot about the desktop web. The desktop web is an area of strategic importance to Facebook. Many people use the desktop web as their primary way of interacting with Facebook, and it's an area that we need to like really support and polish and make an awesome experience for people. So the web's great, but historically there's been a few disadvantages to the web. There's an additional layer of indirection. When you're going to a website, you have to decide to open the browser, you have to decide to type in kind of like a clunky URL, you have to hit enter, then you have to wait for the website to load. The barrier to entry is pretty high. You have to type in a whole bunch of stuff, and it can take you a while. Another thing is there's not a lot of good opportunities for engagement. Sure, you can collect somebody's email address, you can send them email, but the only way they're going to get it is if they already decide to navigate to their email client and are, all right, I'm in the middle of email, but let me like go look at this thing now and get to it. There's not really an easy way to tell people, hey, we know somebody posted on your wall, you want to see it right now probably, or somebody sent you a chat message, we know you likely want to see this right now. And similarly, the web can often be slower than native apps. Historically, when you have a native app, you have the code already there. You don't have to re-download it every time. When you browse to a website, every time you visit the site, you're re-downloading the entire thing. You have to kind of wait for it to parse, and it can be a lot slower than just native code. And another advantage that historically the native has had over the web is push. We know that push drives visitation. Facebook has a lot of experience with push, and we've seen it work really, really well in many cases. We know that people like getting push notifications when things are about them, and we know that they want to see the content. So in the past, we've known that push is great, and we've done a few private API implementations. We've done push using private APIs with UC Browser and Opera Mini, and both were great. Users love them, it was great for the browser, and it was good for Facebook because people can get the content they want, they can click on it, and they can go back to the site. So when we heard that Chrome and others were working on a web push, on a standardized web push implementation, we were really, really excited to build this out as well. And we launched on Chrome desktop and mobile. And similarly to the other times we've launched push, we've seen like really good results. This chart shows the increase in monthly active users as a result of launching desktop push. And like any great growth chart, it just goes up and to the right. So it's really kind of what we want to see from push. So now to talk a little bit about why a browser would care about this, Owen's going to speak.
So why do we, on Chrome, think push notifications is so important? To answer that, we have to take a step back and think about the strengths and the weaknesses of the web, like we've been discussing. So the biggest strength that I'm particularly interested in is reach. So the lack of install friction and like downloading an app, when you compare that to just tapping a link and immediately getting access to it, you can actually see in the numbers that this means that far more users can get to more web content easily. Like here we see from ComScore that of the top 1,000 native apps and mobile web apps, the mobile web has on average 2.5 times more monthly active users. So we think that's really valuable. And if there are any business people in the room, this reach effectively means that you have a very low user acquisition cost, which means business value. And if you're not a business person, just say the word business value to the people on your team, and you can basically get whatever you want. But this business value is real, right? So Flipboard was an app-only newsreader, and last year they launched on the mobile web, and they found it increased their monthly active users by 75%, which is huge. Their CEO stood up on stage and said that all great apps need to be on the web, and especially the mobile web. So this is very real. But there's this question, the web has this strength of reach, but there's this engagement factor which is kind of missing. So native apps are really good at keeping users in and spending a lot of time there. So how do we think about that as Chrome? So I think about it in two ways. Home screen icons, right? You open your phone, you have one button, you tap it, you're in Facebook. Like that's extremely compelling compared to opening a browser and typing in a URL on your keyboard. And secondly, push notifications. So like I said, a number of key use cases just aren't even possible without push notifications. And I think home screen icons, Alex talked about a bit earlier. We won't be going into that here, so we'll focus on push notifications. And so with push notifications, we think that you can get the engagement of a native app with the reach of a web app and kind of bring these two together. And when we look at data from companies other than Facebook, we see this across the board. For example, Beyond the Rack is like a flash sales company that last year launched push notifications, and they found it increased their repeat visits by 50% within 3 months. Okay, so I hope we've now given you a bit of interesting background on why this is interesting and why we think it's so important to businesses and just kind of cool for developers. So now we'll talk about how. So I think this is pretty interesting because what we saw in the demo earlier, Chrome wasn't even running. Facebook wasn't open in a tab in the background somewhere. And yet it was able to run JavaScript in the background to fetch this content from a server, render a notification, and show it on the screen. How is that even possible? Magic. So maybe it's not magic. But if there's one thing you take away from this evening, it's that whenever you see something new on the web and you go, like, how is that possible? How are they doing that? I almost guarantee you that service workers is the answer. But when I say service worker, you probably think of something a bit more like this. It's like a small JavaScript file that we keep on your device and can wake up to fire an event into when a network request is made on your origin. This allows it to intercept that request and respond with something different. How does that help us deliver push notifications? Well, it turns out that with this powerful capability, we can actually flip this diagram. So here we see a different flow where the web server actually sends a message to a push service. In Chrome's case, this is Google Cloud Messaging, with an ID that identifies the device that you want to wake up. And then Google Cloud Messaging keeps this persistent connection open with the device. So it can tell the device, hey, wake up this service worker, and fire an event into it, allowing that service worker to run JavaScript in the background, even if Chrome wasn't even open at that point in time. And actually, there's a note here, which is that when the service worker does wake up, it wakes up kind of without context. So in the case of, say, a Facebook message, it doesn't know what the message is about. It can't read any information about it. So the first thing that you have to do is send a fetch request back to your server to say, hey, why did you wake me up? What's going on? And Nate will dig into that a bit more now as he goes through the code on how you actually implement this on your site.
So yeah, I'm going to go into a little bit more about the technical details and show some code about like kind of a hello world version of this to implement it. So the first thing you want to do is you need to get a notification subscription. You need to actually get a token that you can send notifications to. So step one, register the service worker and then wait for it to be ready. Calling navigator.serviceworker.ready gives you the service worker registration, assuming you've already registered it, when the service worker is ready to go and be in charge of the page. So you get your service worker registration. Then you tell the registration, hey, I want to subscribe to push. So you call registration.pushmanager.subscribe to subscribe for push. One thing to note here is we're adding user visible only true, which means that we understand that we're making a contract with the browser that anytime we get a push event, we're going to show notification. This means that we're actually going to call the show notification code when push events come in to ensure that we're not doing work in the background without the user knowing. This is important to keep in mind because different browsers will apply different penalties if you don't show notification when you say you will. So for example, Chrome will show this like you're doing work in the background message. Firefox might apply some kind of push penalty. And this isn't really something you want to do. It's not a great user experience, and it doesn't like look good for you either. So just keep that in mind. So now that we have our push subscription, or now that we've asked for a push subscription, the user is then going to see an opt-in flow. So they can either they can exit out, they can click block, or they can ideally click allow. So if they exit out or hit block, the promise will reject, and we'll hit our catch function, and we can kind of do whatever we need to do there to maybe do some cleanup or indicate that the user didn't want it. But ideally, they hit allow. Then we get a push. The service worker is going to talk to GCM, and the browser will give us a push token. Now we have a push subscription, and we have to send it back to our server. So this is just kind of custom code. You basically push the subscription back to you. Oh, and one thing to note here is before we were just calling subscribe in the push manager, but you can also, before you do any of this, call notification.requestPermission. This is even before maybe you install your service worker. And what this will allow you to do is it deals with like some weird UX issues you might run into in incognito mode in Chrome, and it can be a little bit cleaner. You don't have to do it; it's totally optional, but it might make things easier. And calling request permission is basically the kind of doing a little bit of this work earlier. So now we have a push subscription. What do we do with it? So let's say somebody posts on your wall and you know, all right, I need to send this notification. Step one is you send a request to the push endpoint, and you're like, all right, like, send the notification down. So GCM or Mozilla's push service or the push service for that browser, it's already there, and it has a persistent connection with the browser. And so it gets the request, and it's like, all right, I know that this request should go to this specific service worker. So it sends a push event that using the persistent connection it already has to the browser, and it's like, all right, wake up the service worker and give it this push event. The service worker then wakes up, and it goes to your server. It fetches the content for the notification. It gets the content back, and then once it gets it back, it's like, all right, browser, here's the notification to show, and then the notification gets displayed. So what does this look like from code? So when you receive a push message in the service worker, the way to do this is first you're going to say, I want to listen to this push event, which basically is run this code anytime I get a push notification. Then the next thing you're going to do is tell it, all right, I got the event. Now this event needs to wait for this work to happen. Because we're using promises here, it's important that we actually tell the event to wait. It's not just going to kind of like run this function synchronously. It could be a little like asynchronous. So we have to tell the event that it needs to wait for all this potentially asynchronous work to happen until it could safely kill the service worker, or maybe like the browser can decide whether or not it has to apply a penalty for not showing a notification. So now that we have the event, we're going to go ahead and we're going to fetch the content for the notification. So we'll hit our server, ask for the notification content, and we'll kind of keep going down into the next step. So once we have the content for the notification, we'll call show notification, and we'll display what we want. You can note here that in the data field, we're adding URL. You can put whatever you want in data, but in this case, we're going to store the URL that we want to have the user click on later. So once you've shown a notification, now the user maybe wants to click on it. So this is example code you could use to handle clicking on a notification. This is a little more complicated than it has to be, but it's a pretty good implementation that deals with some edge cases. You could certainly come up with something way more simpler. So same as before, the first step is going to say, hey, we want to listen to this click event, and then we want to wait for all this work to happen until we agree that we're done with the event. Then the next thing we're going to do is we're going to get the URL from the notification data, and we're also going to call notification close. This is important because in Android, notifications won't always close automatically, so you have to call close to make sure that they actually disappear from the screen. Then the next thing we're going to do is we're going to call clients.matchAll. This is so when somebody, maybe they have a tab of your website already open, you don't want to have a different tab open every time they click on a push notification from you. So you're going to get currently open tabs and to try to kind of minimize the amount of different tabs that have to open from your site. So let's say they have a tab open. Great. So the next thing you can do is you can post a message and wait for a response from this tab. So that post message and wait for a response would be a custom function you write on your own. But basically, you're going to post a message to the tab that's like, all right, please navigate to this site. The tab can then act and be like, all right, like I'm totally OK to navigate now. Let me navigate to this URL. And it can reply back to the service worker saying, hey, I've navigated. We're all good. So then the service worker can go ahead and say, all right, browser, you should focus on this client. Then it'll bring the tab to the foreground, and the user can see the page that you want. So post message and wait for response model is a kind of like the TCP approach to this, where you're posting a message and you're waiting for the service worker to act it. This is useful maybe if like the user is going to write a big post and you don't want to kind of blow that away by just like navigating randomly, or JavaScript's hung or something like that in the window. You could certainly also kind of like have a more UDP approach and just like post the message to the service worker. It's like, please navigate now, and just focus right away and kind of trust that it'll happen. So let's say you have no clients, or like the client rejected the navigate. So then you can just call client open window, URL, and it'll open the URL that you tell it to. It'll focus on that client, and you're good to go as well. So when building this, there's a few fun edge cases you might want to consider. The first one is simultaneous push messages. This one can be a little hairy, but maybe you get a push notification at the same time that you're already fetching content for another push notification, which can introduce a few race conditions between you and your server. The way to solve this really depends on how you've implemented push on your backend, but it's something to keep in mind when you're building stuff like this out. Another thing is showing multiple notifications. If you have like 50 notifications from a site, that can be not the greatest user experience. So in developing this, there were periods of time where I would have like 20 notifications from Facebook. And Facebook notifications are great, but it becomes kind of hard to use your computer when you have 20 notifications all on the side. So an easy way to deal with this is to just use notification tags. And what that will allow you to do is you can replace currently showing notifications with new ones. So if you have a new notification come in with the same tag, you can just kind of replace the old one, and you can use this to minimize the amount of notifications you show. And another thing that you should consider is showing notifications when the page is visible. The browsers don't actually apply kind of a penalty for not showing a notification when the page is already visible, because this is a time when you already would be allowed to run the service worker. And it's kind of not the greatest user experience for you to be on a page and then a bunch of notifications to be popping up for the same page while you're on it. So the service workers can look at currently open clients and see which ones are focused or not, and they can tell, like, all right, this client is focused. I shouldn't actually show a notification right now. And another thing you could consider doing is when pages become visible, clearing out all currently showing notifications as well, because it's another time where they're already on the site. Like, it can be kind of annoying to get a whole bunch of notifications then. So to talk a little, so all these code examples are great. And you're totally welcome to use them, but another really, really great resource is bit.ly/webpushguide, which can kind of walk you through the steps of setting all this up. It goes into much greater detail than here and has a lot of really good code examples. Another pro tip is you can use chrome://serviceworker-internals, and this kind of gives you like a nice service worker console. You can start and stop service workers, and you can give them fake push events. And this is really, really useful for kind of building out your implementation. And it can help like you set stuff up before maybe you've built your backend and your server implementation here. So to talk a little bit about user experience considerations, Owen's going to come back up.
Cool. So I'm going to go through quickly a couple of the things that we've learned since shipping this. So the first thing is just making sure that we'll send notifications that users care about. So I think when I try and consider these different use cases, I try and evaluate things on two axes. How urgent is this, and how important is it to this user? Something that's both urgent and important, like your Uber car has just arrived outside, or like your best friend has sent you a message. Those things are great examples of push notifications. But if it's not urgent and it's not important, it's probably a pretty bad example of something like sending them a notification every day saying, hey, come back and use my website. So maybe don't do that. And it's worth remembering that you might have seen in the demo earlier that there's a tiny little cog on each notification, and the user can tap that and go in and manage the notification settings. So if you kind of abuse your power, it's going to get revoked from you, and then you can't provide the good experience that you want to. So just be careful about it. Secondly is about how to manage your permission requests and like the UX there. So it's important to remember that getting the user to sign up for notifications is a flow on your site the same as any other. So you don't want to have them land on your site for the first time and immediately see a permission request saying, hey, I want to send you notifications, because that thought is like, who are you? Like, what do you want from me? So this is a nice example from Twitter where if you go in the DM panel, they say, hey, do you want to receive notifications for new messages? If you click enable notifications, then they pop up a permission request saying twitter.com wants to send you notifications. So I think that kind of model is really nice. The final UX tip I'll give you is about deduplicating with native. So this is an interesting issue if you have both a native app and a web app for your company, that if the user has installed the native app but also opted in on the web app, they might get everything twice. And so there's a few different ways you can try and solve this. Unfortunately, there's no perfect solution. So you can use heuristics. So for example, if the user's logged in on the web and on native, and it's on a device that looks pretty similar, like it's the same kind of size and things. You can just choose on the back end to only send to whichever one you would prefer. Something else you can do, which is kind of nice, is when you do the initial permissions opt-in and you say like enable push notifications, whatever your button says, when they press that, you can actually fire an intent into your native app, and if your app is installed, it'll just take the user into the native app and tell them that they've already got push turned on or something. And if the app isn't installed, you can specify a fallback URL, so you can basically say if the app is installed, go to the app. If not, stay on the page. So that's a nice thing you can do as well. And to wrap up, I want to tell you a couple things that are coming next in terms of these APIs in Chrome. So the first thing is push payload. So our friends over at Mozilla, who actually sat over here, have already implemented this feature, so kudos to them. So earlier I said that you have to make this network request back to your server to find out like what you should be showing. Push payload removes that by allowing you to send data down with these push messages, so you can just send down the text to be shown or whatever it happens to be. So you can just remove that fetch, which is a really nice feature. Try it out in Firefox, and hopefully it should all work in Chrome when our version lands. The second thing we're currently exploring, we don't have a timeline for this yet, but it's silent push. So earlier Nate mentioned how there's this kind of contract between you and the browser that if you receive a push, you're going to show a notification. So you're not just kind of running in the background constantly without the user knowing. So we're exploring this idea that sites can have a kind of quota so they can run some amount in the background to like synchronize data. So then, so imagine you're a news app, you can download the latest news each morning, so when they get in the subway, they have it available offline, those kind of things. So that's really exciting. And you have payload there as well. Okay, so to conclude, all of this stuff is now possible thanks to Service Worker, which is a new standard which has good broad support. It was a standard designed together by Mozilla and Google and a bunch of others in the web standards community. And we're really excited about this because push notifications fundamentally enabled a whole bunch of new use cases on mobile, and all of those have just become possible on the web, so you guys are all able to take full advantage of that. So we can't wait to see what you build next with it. And that's it. So thank you very much. And you should follow us all on Twitter.